So what it says is that you're given the value of the parameter t, you're asked to find the corresponding reference number. So for these problems, you really have to draw the unit circle and then patiently get the reference number. So here's the situation. There's the unit circle. Okay. So 5 pi over 4. Remember, each one of these, this is pi over 2, right? So pi over 4 is kind of halfway in between. So if you have 5 of them, we'll take you over there. So right there. So this, see this? This is t equal to 5 pi over 4. It's positive, so we went counterclockwise, and 5 of these slices of pizza, think about it like that, 1, 2, 3, 4, 5. They'll take you there. Now, the reference number is the smallest positive or the shortest distance to the x-axis. What when it's talking about distance means it's positive, so reference number is always a positive. Don't give me a negative number for reference number. Okay, so just think about it. There is the shortest, see that right there, this is the shortest distance to the x-axis, and if you look at it, it's going to be t bar equal to pi over 4. Okay, this tip is too, okay, let me make it shorter. Okay, so all right, the other one, we did this one. Let's go and do this one. Let me draw that. Okay, so remember, 7 pi over 3 can be written as 2 pi plus pi over 3. Okay, so if this is the unit circle, all right, so 2 pi, you start here, just always start here, 1 and 0. You go 2 pi, and then you go another pi over 3, it lands you right there. Okay, so remember, you went clockwise by 2 pi, and on top of that, you want another 2 pi over 3. So it's right there. The shortest distance is going to be pi over 3. Okay. I think I can erase these. We don't need it anymore. All right. So let's take care of this fellow now. Let's take care of this. So remember, this is, you can write it as, for example, minus pi over 3. That's one way of doing the problem. So let's think about it for a second. There's the unit circle. Minus pi means that you start here and you go clockwise. So when you go clockwise by minus pi, you end up at this location, and then you go another pi over 3. It'll take you right there. So it takes you to this place, and the parameter is all the way to that point. The shortest distance to the x-axis, positive obviously, always positive, is pi over 3. Okay, and this is obvious because pi over 6 is already in the first quadrant. So pi over 6 is somewhere here. So this is your pi over 6. This is your t. This is your t, and because it's the first quadrant, the t bar is always equal to t, and it's equal to pi over 6. Okay, so let's go to the next problem. All right, so it says find the reference number for each of the values of of t. So you look at, let's start with this, 2 pi over 3. 2 pi over 3, here's the unit circle. Okay. 2 pi over 3 is, will put you, remember this is pi over 2, this is pi. 2 pi over 3 is somewhere here. So right there. So this length, in principle, it is 2 pi over 3. So when you look at the reference number, is the shortest distance to the x-axis, which is this. So if you think about it, it's going to be pi minus 2 pi over 3, and that is pi over pi over 3, right? Pi over 3. So that's for this. And for that fellow, let's draw the unit circle. Remember, 4 pi over 3 is pi plus pi over 3. Pi plus pi over 3. This. Okay, pi plus pi over 3, right there. Okay, so you go by the amount pi. This is going counterclockwise, positive. And another pi over 3, it'll put you over here. So this is the value of t, like that. And the shortest distance to the x-axis is this much, which is pi over 3. So t hat is pi over 3. Okay. All right, this is the last problem, but I have drawn several versions of this unit circle because I don't want to mess it up too much. So here, okay, it says use the figure. This is the figure, and to determine the real number t, to determine the coordinates of the terminal point associated with the given real number t. So t equal to 1. T equal to 1 means that we're right here. Okay, we're right here, right there. So this is distance 1, this is distance 2, this is distance 3, etc. And the idea is that you eyeball, or I mean, I don't have a ruler here, you eyeball and estimate these x's, x and y. So when I eyeball this thing, I don't know, I get maybe x equal to 0.6 or something like that. Okay, and the height is approximately 0.8. Okay, but it says rounded to 1 decimal point, so don't go 0.65 or 0.85. So that's this. The next one is 2.5. So there is 2, and 2.5 will take you to this tick mark right there. So this is 2.5. There we are. Okay, and you eyeball this. So it looks like, that's kind of hard to say. I don't have a ruler here. So approximately x is negative. So negative 0.7. I'm assuming that it lands here. And the height is positive. So y is roughly there. So 0.6. Okay. Next one is negative 1.1. So if you go backward, this is negative 1, and 1.1 will put you right there. Okay. So if you look at eyeball these x's and y's, a little bit there. So you get x equal to minus, x equal to plus 0.1. Actually, it's a little bit on the left side, and the height is negative, which is negative 0. Almost 0.9, something like that. Last one, 0.42. Okay, I don't run out of these things, so let me do it over here. So let me erase this. Get rid of this. Don't want that. Okay, so 4.2. So we go 1, 2, 3, 4. 4.2 will land you right there. 4.2, and you eyeball the coordinates to within 1 decimal point, and you're going to get x equal to almost minus 0. I don't know, let's look at 0.4, and the y equal to minus 0. I don't know, looks like 0.8, something like that. All right, that takes care of it.